I'm Professor Andrew White. I'm a assistant professor in the chemical engineering department at University of Rochester. I'm going to give you a little bit of an overview of my research. Uh, so this is my group. This is me. And these are some PhD undergraduate and master's students at my group. This is a nice view from the fourth floor of Wegmans Hall, where the chemical engineering department is located. So our department is located in the same building as data science and computer science, and we have a lot of overlap, and we have collaborators in these two departments. And you'll see a lot of our work is computationally motivated, but most of the students still have chemistry and chemical engineering backgrounds. So my group, we like to think really far out, like what will chemistry and chemical engineering look like in 10 years? So in the background, what you'll see is a video showing a laboratory setup from a company called Emerald Cloud Labs. And they provide the ability to do experiments in the cloud just through a web interface called an API. And we like to think about in the future, if you can have a computer order up experiments 24 hours a day and highly concurrent, what could you do with this kind of capability? So my group, we're thinking about how techniques like AI and deep learning and computer simulations can enable us to design materials in the cloud without any experiments, purely computationally driven. So maybe in the future, you see in this little text I have here, we can just order up what components we want, what material properties we want, what costs we want to pay, what our compute and experiment budget is, and then an AI will design the material that matches these constraints. So this is, this is a long ways out, but we're thinking about all of the steps that go into this kind of a dream process. So this is called iterative molecular design or iterative materials design. And in my group, we work on these different components of it. There's the experiments, there's model improvement, that is how do you take the outcome of an experiment and improve your model. And then there's computational simulations, this is the modeling part of it. And then there's this AI part, which is design of experiments with active learning. So we like to look at physics-based models, right? So we still do, we do molecular simulation, computer simulation. These use principles of chemistry and physics. And then we also use deep learning, which are empirically driven models. Sorry about my dog here. I'm gonna just kind of give a quick overview of some of the different areas that go into this. So, that was a cartoon before. These are some of the methods we use in this process. And the first one, improving physics-based models from experimental data. This is like molecular simulation. Improving predictions from experimental data. This is where we use empirical methods like deep learning. And this active learning with predictive models. This is where we put it all together with an AI-directed process. So let me just mention simulations. So you may know from your undergraduate that we're actually very good now at predicting what is the interaction between two atoms. Quantum chemistry has really reached a golden age where we're able to predict energies quite well. Simulations allow us to go from the energies between two atoms to actually understanding the ensemble of molecules. So that's what a simulation does, is it kind of does, it takes the energy between atoms and allows you to predict the property of any material. Sorry, my dog is really excited about another dog going for a walk. This is part of life in COVID-19. All right, so molecular simulation is the tool we use to understand, it's the latent model. It gives us the information about all the atoms, where they are in every property of the system. So if we can reconstruct the simulation, then we know how to interpret our experimental data. I'm just going to touch on the other methods. Graph neural networks is what we use to predict properties without an experiment. So before we use molecular simulation to infer what's going on from an experiment, and then we use these empirical methods to predict the outcome of an experiment without having conducted, with maybe information from molecular simulation. And graph neural networks are a category of supervised learning. If any of you have taken a machine learning class or statistical learning class, then you may be familiar with supervised learning. I'm not going to get into this too much because it's a deep learning method, but that's the sort of one of the more modern methods which we use in our research group. And active learning is a method which we use to predict or choose which experiment to do next. And it's sort of the whole directing process. This is where we use AI to choose which experiments to do. And this is kind of how we can take the human out of the loop in some sense. Of course, we always want to have humans involved in this decision-making process. But this sort of AI thing here, this is what allows you to run experiments continuously. So you have short experiments or experiments which you can do highly parallelized. Then this can take out a lot of the manual labor, like choosing which conditions to run and which experiments to do. So this is the whole process. My group works on all the components in here. I have a little, this is kind of goofy, but we say free space down here is that these generative models, being able to propose new molecular conditions, this has been an enormous amount of area in here, and everybody's working on this. So I think there's a lot of outstanding research going on here, so we don't try to get involved in this area. But this is a really exciting area, these generative models. You may have seen this in the news, things like AI that can generate human faces for faces that have never been seen before. Well, there's AI that can generate molecules for molecules that have never been seen before. Okay. I would just mention my group also works in augmented reality in higher education. It's kind of an outreach or a side project, but there's a great group of people at University of Rochester that do augmented reality and optics and computer science, and we participate in this consortium. With that, I think I'm all set. Thank you.